Hello everyone, I'm going to complete the 10 problems that I gave you last week regarding the laws of exponents. And we're going to cover this first one here. It says 2k to the fourth times 4k. First thing I'm noticing is that I have 2k's multiplied with the same base. I'm going to reorganize everything so everything that's similar is next to each other. So when rewritten, we have a 2 times 4, which is an 8. And then we have a k to the fourth times a k to the first. And whenever you have the same base multiplied, you can add the exponents. And so we end up with 8k to the fifth power. For our next problem, once again, we pretty much have a string of multiplication, and we can rearrange the problem so that similar bases are next to each other. And use our rule that says when you have two of the same base multiplied, you add exponents. So rewritten here, we have a 2 times 2, which is 4. We have a x to the third times x to the negative 1, which is an x to the third plus a minus 1. And then we have a y to the negative 3 times a y to the 3, which is y to the negative 3 plus 3. And we end up with 4x to the second, y to the 0. And remember that anything to the 0 power is 1. So we're just left with the 4x to the second. For our third problem, we have 4a to the third in parentheses to the power of 2. And there's a rule that says that whenever you have this exponent on the outside of parentheses, you need to multiply exponents. So remember that the 4 is the first, and so we multiply the 2 times the 1, and the a to the third, we have the 3 times the 2, which gives us a 6. So we end up with 16a to the sixth power. For our fourth problem, it's very similar to the third. The only difference really is that you have a negative exponent on the outside of parentheses. But that doesn't really change how we apply the rule. We still multiply that negative 4 towards those exponents. So we have a 2 to the negative 4, x to the negative 8. And if we cross the line, we change the sign of the exponent. Remember that our answer should contain only positive exponents. And remember that we essentially have a 1 chilling, hanging out in front here. 1 times anything is itself. So when we cross the line and change the sign with these guys going down below, our 1 is still hanging out up top. So we have a 1 over 2 to the fourth x to the eighth. If you want to evaluate that exponent for you can, and you're going to end up with 16x to the eighth power. Problem 5, we have this big division problem with the same base in numerator and denominator, and we simply need to use the rule that says when you have the same base in the numerator and denominator, you can subtract exponents. So we're going to look at the x in the numerator and denominator. We're going to subtract 3 from the 4. We will subtract the negative 3 from the negative 4. So that's a minus 4 minus a minus 3. We'll do the same thing with the z. You have a z to the minus 3 minus 4 power. So just a side note, I could have rewritten this a bit differently if I wanted. I can subtract the top exponent from the bottom if I want. And in this case, I would actually do that because that would leave me with positive exponents to deal with. Let me go ahead and show you what I mean. I can rewrite in a different way. I can go from the top to the bottom. So I have a y to the minus 3 and then subtract minus 4. And then the z to the fourth and then subtract the minus 3. And the advantage of doing that is now when I simplify, I'm left with positive exponents. And so I don't have to worry about Oops. I don't have to worry about crossing the line and changing the sign of the negative exponent. Okay, so for problem number 6, we have exponent on the outside of parentheses here, and then we have multiplied times this term 2n to the negative 1. We first need to get rid of this parenthesis by multiplying the exponents, which is going to give us an n to the 9 power times 2n to the negative 1. And I see that I have two of the same base multiplied, so I'm going to rearrange that I have 2n to the negative 1 times n to the 9. And then we simply just add the exponents together. You have a 2n to the negative 1 plus 9, and that gives us 2n to the 8th power. For problem number 7 here, we have a quotient, and we need to first evaluate that negative exponent. And so I'm going to multiply in that negative 1, and that's 2 to the negative 1, and m to the negative 2 power. That's over m to the positive 2 power. So at this point here, some of you might be like, let's just get rid of those negative exponents. Others of you might see that quotient rule. It says when you have two of the same base dividing, you can subtract. And I'll go ahead and do that. I'll go ahead and move that minus 2 down, subtract it from the 2 down below. And I'll go ahead and cross the line and change the sign, which is 2 to the negative 1. What's left up top? 1. And we have a 1 over 2m to the 4th power. Okay, so for our next problem, we have a string of multiplication. To get to the bases inside the parentheses, I have to multiply this negative 3, and I have a b8 to the 4. I have a 2 to the negative 3 because that exponent of 1. I have a b to the negative 3 because of that exponent of 1. And I have a to the negative 12th power. So from here, I'm going to go ahead and rearrange so that I have the same bases next to each other. And once I've done that, I can add up my exponents. 1 plus a minus 3 is a minus 2. 4 plus a minus 12 is a minus 8. And so we have to evaluate these negative exponents. And so all of these are going down below in our denominator. And once again, we have a 1 in the numerator. I can evaluate this 2 to the 3rd to be an 8. Or if I left it there, I would mark any points off. Okay, next problem. Let's evaluate that exponent on the outside of parentheses, and that gives us an x to the negative 12 and times x to the 4th over 2x to the negative 3 power. I'm going to go ahead and take care of my numerator first, and that gives us, we have a minus 12 plus 4, that's a minus 8, on top of 2x to the negative 3 power. So at this point, I see that I have a numerator and denominator with the same base. I'm going to go ahead and pull the negative 8 down below and subtract it from the minus 3 because I see that I'm going to get a minus 8, and that's going to result in a positive exponent in our denominator. Okay, so for our last problem, let's go ahead and evaluate this power of 3 and multiply exponents. And so I'm going to go ahead and write up top here. We're going to have a 2 to the 3rd. We're going to have a x to the 9, multiplying exponent 2. And a z to the 6th. This is all over. I'm going to go ahead and cut this a little short. And I recognize that I have the same bases multiplied in the denominator. I'm going to take the 3, add it to the minus 4, giving us a minus 1. And take the little y has the same base down we have a y to the fourth, and then a z to the second times a z to the third. Adding exponents will give us a z to the sixth power. So from here, we will have a, let's see, 2 to the third, I'm going to write that as an 8. And I'm going to bring the minus 1 up into the numerator and subtract it from the 9. So I have a x to the 9 minus a minus 1. And then y to the fourth, one down below. And we have z over z. So I'm going to subtract the 5 from the 6 up top. And we're left with x to the 10, 8x to 10, z to the first over y to the fourth power. So I just took everyone through all 10 problems using properties of exponents. And I just wanted to acknowledge that you can complete these problems by simply using the negative exponent rule, cross the line and change the sign, and evaluating what an exponent means. An exponent tells you how many times you need to multiply a base. For instance, if you look here at problem 2, all I did is took the y to the negative 3 and the x to the negative 1 down below here. And at this point, I could expand using y to the third. I could expand y times y times y. I could expand x to the third, x times x times x. And then I could cross off 1x in the denominator and numerator, being left with 2 up top. I could cross off 1y in the numerator and denominator, leaving us with 2 y's down below. So please look through these and just see what I've done as far as evaluating negative exponents. You can complete these using only negative exponent rule and what it means to have an exponent. Okay, ask me if you have any questions. Hope you had a good weekend.